Okay, let's start with this paper. Okay, this is going to be paper 2, October, November 2019. Yeah. So take note of the time. It's going to be 1 hour 15 minutes. Okay. Now, so let's actually have a look at the first question over here. In the periodic table, the p block contains elements whose outer electrons are found in the p subshell. Electrons in the p block shows a general increase in the first ionization energy as the atomic number increases. Okay, draw the shape of p orbital. So let's actually draw the shape of p orbital. Okay, this is going to be the shape of p orbital. Done. Okay, write an equation to show the first ionization energy of silicon. Okay, silicon. Okay, and then you need to actually change into Si plus, and then you remove the electron. Okay, you always remove the electron in form of gas. Okay, so in form of gas. So this is going to be the first ionization energy. So if you do not actually give over here the gas, then it's wrong. Okay, then it's wrong. Now explain why there is a general increase in first ionization energies of the element across period 3. So Victoria, can you actually explain why when you go across period 3, the ionization energy increases?
Is it because of the charge, the proton? Yes, sir.
Yes, as you go across the period, the same period, so the proton number increases. Okay, the proton number increases. So what happens when the proton number increases? What can you actually tell me about the number of shells? Is it the same, or is there any change in number of shells?
The number of shells the same.
Okay, number of shells the same. So when the number of shells are the same, what can you say about the shielding effect?
Constant.
Okay, number of shell is the same. Shielding effect is constant. Number of shells, same. Constant shielding effect. So if it is constant shielding effect, what can you say about the charge? Okay, the nuclear charge, therefore, just now you mentioned something.
Oh, increase.
Increases. So it's going to be more difficult
to
remove. Why? To remove the one electron, because there is a stronger attraction of the electrons towards the nucleus. So you need to actually put all these things over here. Okay, so as you go across the period 3, as we go across period 3, okay, proton number increases, shielding effect is constant because the same number of shells. There is an increase in nuclear charge, pulling all the electrons closer, or attracting, okay, that would be a better word, attracting all the electrons closer to the nucleus. Therefore, more energy is needed to remove or to overcome the attraction. Okay, whatever it is, okay, please actually focus on the important part over here. You need to mention about proton number. You need to mention about the number of shells. Okay, you are talking about the nuclear charge, okay, and then stronger attraction and so on. So how do you actually construct this answer? I leave it to you. Okay, so as long you have all the points, okay, it's okay. Okay, now next part. Okay, element A is in the P block, and the graph shows the successive ionization energy for the removal of the first 10 electrons of A. Okay, so you keep on removing, yeah, the 10 electrons. Okay, first 10, that doesn't mean that they only have 10 electrons. Okay, state and explain the group of the periodic table that element A belongs to. Okay, which group number and what is your explanation? So how, Jody? Can you tell us what is the answer?
Group 3.
Why group 3?
The change in ionization energy from 3 to 4 high. Yeah.
Explain more. Explain more. If you are actually writing down your answer, what would you actually explain?
I only read like that.
Okay, you just mentioned group 3. Okay, fine. Okay, so here group 3. But I told you in A level, okay, please actually write group 13. Okay, so it's group 13. So explanation. So it's 2 marks here. So you already get 1 mark. So what is your another 1 mark? Please actually tell me. The reason. Yeah.
Large change in ionization energy.
Change or large increase?
Large increase.
Okay, large increase between?
In ionization energy.
Of what?
Oh, from the 3rd electron removed and the 4th.
Yes, you need to mention, okay, the large increase between the 3rd and 4th ionization energy. So that means, okay, that means you can actually write down more. That means there are 3 valence electron and it belongs to group 13. Okay, so let's move on further. Okay, silicon is found in many compounds in the Earth's crust. Silicon has only 3 naturally occurring isotopes. Okay, so there are 3. The table shows the data, and then you have the relative isotopic mass. Actually, all this isotopic mass is already shown over here. Okay, so a sample of silicon has 92.2%. So this is 92.2%. The total percentage of abundance in the sample is 7.8%. So it means, let's say this is X, this is Y. So X plus Y is 7.8%. The relative atomic mass of AR of the silicon in the sample is 28.09. Okay, 28.09. Calculate the percentage of abundance of this. Okay, of the this one. So it means I want what is going to be Y. Okay, give your answer to 1 decimal places. Okay, let's actually try to calculate. Sample total percentage, total abundance of this 7.8. Okay. Calculate. Okay, so 28.09. Or let's say actually instead of putting X and Y, we know that if you add all of them, X plus Y is going to be 7.8. Can I, since I'm looking for Y, okay, since I'm looking for Y, I can actually eliminate by using the X. So what is X? X is 7.8 minus Y. Okay, let's actually apply some maths over here. So X is 7.8 minus Y. Okay, instead of using X, I will use everything in Y form. Okay, So 28.09 equals to 92.2% times 28 plus 7.8 minus y over 100 times 29 plus y over 100 times 30. This one times by this 2809. Find out what is y. Charlton, give me answer. What is y?
Wait.
Waiting.
One point two.
Okay. So y is 2809 minus 2807.8. Yep, you're right. So 1.2%. Now, some students will get problem if they actually don't change it into here. So you will still have another one which is going to be x. So how do I find x and so on? So I think that's the problem here. So that's going to be the answer, 1.2. So let's actually move on further. Silicon reacts with nitrogen gas to form this, okay? And Si3N4, okay, is a solid with a melting point of 1900. It is insoluble in water, does not conduct electricity when molten. So insoluble in water and doesn't conduct electricity when molten, okay? So when something do not actually conduct electricity in molten stage, okay, that's going to be, we are talking about a covalent bonding, okay, a covalent molecule. So I know that this is going to be covalent. Molten, okay, if they conduct electricity, then they might be either metal or they might be ionic, okay. So in this case, this is covalent. Insoluble in water, okay, insoluble in water. So generally covalent molecules, okay, they do not they are not soluble in water. So they also the reason why they are not soluble in water, because they don't have any charge, okay, they cannot form any charged ion, no charged ion. What else that you can actually identify over here? What can you say about 1900 degree Celsius? Aneta, is 1900 degrees Celsius as melting point is high or low?
Low.
It's high.
That was high. That was giant.
Okay. So its melting point is very high. It means it means the solid want to actually, you want to melt the solid to become liquid. Okay, you need to heat them up to 1900. So the temperature is quite high, okay, to melt the solid. So it means the type of bonding, because of that, okay, it's a giant molecule. What type of giant molecules? Type of bonding. So it's a giant covalent molecule. Okay, it's a giant covalent molecule. What kind of bonding? Okay, so of course it's a covalent. It has covalent bonding. Why? Because it's does not because does not conduct electricity in molten. In molten state. And what else? Okay, you can actually say they are insoluble in water, so therefore there is no charged ion. Okay, there's no charged ion or particles. Okay, that one can actually you can explain for does not conduct electricity also. Okay, I think the insoluble in water, I think more towards the insoluble in water also. Okay, so all this, okay, means three marks are given. So the 3 marks, okay, they want you to mention about giant, okay, to identify giant based on the melting point. Covalent bonding is one of it, and then the charged particles, that's another one of it. Okay, so 3 points must be there. Okay, so if you go for next one, sulfur containing compounds, okay, such as this are found in fossil fuels, and they produce SO2. They already give you some idea over there. Okay, when they actually burn, you can actually get SO2. So let's actually see C2H5SH. Okay, when you actually burn with oxygen, what will they give you? Okay, this one, I think whenever you have carbon, hydrocarbons generally, when you have complete combustion, they must give you carbon dioxide and water, whether you like it or not, it will be there. But because now there is S, okay, so there is definitely SO2, so you plus SO2. So you just need to actually balance this equation. Okay, how do we balance? 2 carbon, you put 2 there. Hydrogen, okay, you have 6 hydrogen, so I'm expecting to have 3 over here. So 4 oxygen, 7 oxygen, 7 plus 2 is going to be 9 oxygen. So you want 9, so just put 9 over 2. Okay, is this a good equation when it comes to chemistry? Not really, because you need to times everything by 2. So you times everything by 2. Okay, so I will read 9 times by 2 is going to be 4. Times by 2 is 6. So times by 2. And then whenever you write any equation, please actually write down the state. If you are not sure, it's okay to actually say it's going to be solid, doesn't matter, okay, if you're not sure. But this one, definitely you are going to have in form of gas, okay. And that this one is also in form of gas. This is going to be liquid, okay. This one is going to be in form of gas, okay. You can write it down. But for this particular question, they do not deduct for the states, okay. But please be mindful every single time when you write any equation, please include the states, okay. State why the presence of SO2 in atmosphere has environmental consequences. Describe one consequences on the environment. Jody, what do you think? Having SO2 will give you what? How about Nicole Trisha? Having SO2 will give you what? SO2 will give you what? SO2 plus H2O. That's going to actually give you what? Lavi? The consequence.
It's going to corrode the building.
What is the consequences?
Lightning.
Lightning. No? How come having SO2 will actually cause lightning? Lightning is actually something that is actually, no. When in this case, the presence of SO2 in the atmosphere, okay, the consequences is going to cause you acid rain. Okay, that's going to be the answer. So you will get acid rain. Okay, so they react. Okay, it causes acid rain. Okay, 2 marks here. It causes acid rain. Okay, how it actually cause acid rain? Okay, by dissolving with rainwater. Okay, dissolving in rainwater to form sulfurous acid or sulfuric acid. Both of these can be formed. Okay, you can say to form sulfuric acid. I think easier, sulfuric acid. And what happens? Okay, the consequences. Yeah, they say consequences. Once you have sulfuric acid, okay, when they go into the let's say what this will do. So when they go to the soil, they decrease the pH of the soil. When they go to the lake, they decrease the pH of the lake. So what happens if it is soil? So some plants will die. Okay, if you go to the lake, pH decrease, okay, the fish will die. So those are the things that they want you to actually write down. Or you can also say that it will damage the structure of building. Okay, some building they actually have metal structure. So they once they come into contact with this, okay, of course the metal structure will be damaged as well. So anything, okay, make sure that this one, okay, this is going to be how, okay, or what is the consequences and how it will affect the environment. You need to still mention about this in order to get the 2 marks. Okay, some
Sir,
students, they don't actually mention it fully, so they lose marks.
Sir.
Yeah.
So we cannot use fraction to balance the equation, yeah, for like CI.
Actually, for your exam, okay, when I see the marking key over here, they have used fraction. But try not to actually leave it as a fraction, because once it becomes a habit, okay, it will affect when it comes to, you can actually use a fraction on certain cases. For example, if let's say you want to actually find the enthalpy of combustion or something, okay, of course, if it is going to be like something enthalpy of combustion of A. So if I write maybe something, if you balance, you get something like this to give you like this, for example. Okay, let's say for example. But enthalpy of combustion is when 1 mole completely burn to give you the product, right? So in this case, you can leave it in a fraction. Okay, but okay, like some other cases is like if it is formation, for example, sodium iodide. If you want to form 1 mole of sodium iodide in solid form, you are getting it from sodium solid plus half I2 in form of solid. Okay, that's going to be the enthalpy of formation. So in this case, it's accepted. Okay, it's accepted. But other than that, okay, whenever you can avoid, please try to avoid. Okay, please try to use the full version. But in this particular paper, yes, they did give it in a fraction. Okay, but I don't think so. You need to give it in fraction.
Okay, sir.
Yeah. There's still 2 more questions. Okay, maybe can we just finish it? Okay, let's actually finish it. So now in one reaction, SO2 reacts with O3, is ozone, yeah, until a dynamic equilibrium is established. Okay, state and explain the effect of increasing the pressure on the composition of the equilibrium. So I will go very fast. This is 1, 1, 1, 1. All of them are gas, so 2 and 2. So the number of moles are the same. So the answer is going to be no effect. Okay, no effect. So you just explain that the number of moles at the reactant and then the number of moles of the product, they are the same, but make sure the one that you count must be all in gases. Okay, must be all in gases. No effect. In the other reaction, a different equilibrium is established at 300 Kelvin as shown. Suggests a temperature needed to increase the yield of SO3. It means I want to actually move to the right hand side. Okay, I want to move to the right hand side. So do I increase the temperature or do I decrease the temperature? So I like to actually write it like this. If it is positive, I told you, if it is negative, just put hot. If it is positive, put cold. And then this side, hot. So let's say if I increase the temperature, okay, if I increase the temperature, according to LCP, you need to decrease the temperature. How do you decrease the temperature? By moving from hot to cold. And you can see that, okay, the position of the equilibrium is moving to the right. So it means what I need to do, I just need to increase the temperature. Trial and error, yeah. So in this case, I found out. But let's say when you try in the beginning, you say temperature must be decreased. This is the answer, yeah. But let's say you found out like temperature must decrease. So how? So temperature decrease according to LCP, temperature must be increased. So temperature increase, you will actually show it like this. So if you use this condition, the position of the equilibrium will go to the backward reaction side. So in this case, it's not suitable because I want to go to here. So it means the answer is, okay, is temperature is high. So when they say suggest a temperature needed, please suggest something that is higher than 300. Cannot just say higher temperature. It's definitely cannot, it's not accepted. So maybe 600 Kelvin. I'll suggest 600 Kelvin. Okay, 600 Kelvin. Why? Okay, because the forward reaction, okay, the forward reaction is endothermic. Okay, you just mentioned the forward reaction is endothermic, and increasing the temperature favors the forward reaction. So what will be given as your mark? 600. They will actually mention this one, endothermic, or the forward, it favors the endothermic reaction or something like that. Okay, this will actually give you the 2 marks. Okay, that's all for today. I will actually start with question 2 next time. Okay, please actually try to finish everything also so that we can actually go through everything. Yeah. Thank you guys. See you.
Bye, sir.
Bye,
Yeah,
sir.
see you.
Bye,
Bye.
sir.
Yeah.
Yes, sir.